Good afternoon, everybody. I hope you're all back into the room again and that we can continue with our webinar. We're so glad for this opportunity to work with everybody in the webinar and to see all the faces that's joining us that we never saw before. Everything, we're so glad. We want to now welcome Mr. James Ramabu. As previously said, he studied until master's level at UT, and he is doing his research in computer education, computer programming education, and he has got a very nice program that he's using for actively engaging students for programming. I'm very sure the teachers and everybody will be very, very interested in this program that you started to implement. Thank you. I'm giving it over to Mr. Ramabu. Just again, for people that are connected late, please put your questions in the chat box and we will do it, the questions afterwards. Otherwise, you can email the questions to Bertie and he will get the questions that you can do it anonymous and he will ask the questions afterwards.
Okay,
thanks, Mr. Ramabu. You can start.
Thank you, Prof. Joey, and the organizers of this workshop. I think so far it was worthwhile. I learned a lot personally. Thank you, Prof. Lister. I always read your work, and it was an honor today to see your face. Thank you very much, and all the speakers. I'm going to share my presentation now. Okay. As indicated, my name is James Ramabu. I work for the Department of Computer Science at Tshwane University of Technology. Currently, I'm doing a PhD with the University of South Africa within the area of programming education. I started doing this qualification with them since 2017, and then we're still continuing. I've been active in the area of programming education in terms of both teaching and research. So in 2018, what happened is that I started to have interest in teaching programming using physical objects, or you can refer to that as manipulatives. Firstly, I wanted to know if there are people who are using these manipulatives. And then I have to ask this question to Special Interest Group on Computer Science Education. I'm a member of SIC CSE. I'm sure that some of you are members as well. Special Interest Group on Computer Science Education is a subgroup of ACM focusing on computer science education. So for us to see if educators are using physical manipulatives or any other objects to teach programming or assist them teaching programming, we posted this question in the mailing list. If anyone has tried using manipulatives in teaching programming concepts, or know of anyone else who has, could they please email? And then that was my email address, and that was posted in February 2019. It was interesting that we found educators making use of many tools, many objects that do not have a link to computer science, but they help students understand some of the concepts. Let me just share with you the report that I got from the group. This is the summary of what I received. I compiled, I think I got 21 responses from a special interest group on computer science education. And then Some of them suggested Russian dolls. I think this was used for teaching recursive functions. Some of them suggested the use of the deck of cards for teaching arrays and linked lists. And then some of them used the students as manipulatives to emphasize sorting. What was interesting again was, where is that one? Yes, the use of cups, the use of two classes to indicate that the two numbers are swapping, or whatever that is inside those variables can swap. So this person made use of the classes and the third class to indicate swapping. If you want this document, you can email me, I can share it with you. All these responses, they were not edited. I copied them as they were sent to me by a special interest group on computer science education members. And this is what they did. This is what they used to teach programming, introductory programming. This is what they used to emphasize some of the concepts in the introductory programming. Okay, so after I have noted that the majority of computer science educators used this object to teach programming, I tried it out myself through using cups. If I can go back to my presentation again. Great. And then what happened is that I wanted to make use of cups just to test if this thing is working. I had this question posted to students, and then it says if X is 8, Y is 10, T is 15, what is the value of X and Y after the execution of the given code below? T is equal to X, Y is equal to Y, Y is equal to T. And this question was given to students who were already introduced to programming. So I think they were somewhere they were busy with decisions and loops, and we came with these questions to test if they really understood the introductory concept of program execution. And then what was interesting is that 12 out of 30 students indicated that the value of Y is 15. And then when you check why they said so is because here you see Y is equal to T. And then what is the value of Y? T here. The value of T is no more 15 because it was overwritten by the first line there, which is T is equal to X. But 12 out of 30 students indicated that the value of Y is 15. So I think this traces back to what Prof. Raymond Lister said about tracing. They cannot trace back and say that the value of T changed. And now when the value of Y has to be with the new value of T here, the new value of T has to be copied inside Y. Okay, so I had a colleague, we had 30 students, and then we divided them into two. I have a colleague who taught the other 15 students in the other class, and then I remained with 15 students. So in my experimental class, I taught them, or I did correction with them using this experiment of cups. And my colleagues on the other side, they did not make use of these manipulatives. So this cup will represent variable x, this cup will represent variable y, this cup variable t, and those papers with numbers in the cups, they represent the values in the variables. So as when I explained t is equal to x, I had to look for another paper and write and copy the value of x and then put it inside the cup, the teacup, and remove whatever paper that is inside the tea and throw it away, which is the demonstration of overwriting. It is replacing the old value until we come to a point where we demonstrate y is equal to t. And the response was, oh, okay, that's how it works. And I think that's a good feedback as an introductory programming teacher. When you teach and you hear this kind of feedback, you must know that at least you are doing something right. The student understand what you are doing. Whatever method of teaching you're using is working, because when you get feedback, it validates the method of teaching you're using. So as time goes, I think it was in 2020, COVID-19 happened. And then the main focus was that I wanted to experiment many physical objects. I had to look for the decision statement and look for the appropriate physical object to demonstrate decisions. I had to look for loops and demonstrate again, and then the arrays. But COVID-19 happened. That's where we shifted away from physical manipulatives and moved to visual. Actually, at that time, I called it visual manipulatives, where I started to design something similar to physical manipulatives in the form of a program or a program animation. Okay, firstly, we had something like this. Okay, let's read this question. I will show you how I demonstrated this in the next slide. What will be the value of k and t after the following program code has compiled into k t? Case 1, case 2, k is equal to t. So with a little program that we designed, we had the code in this list box. And then we had a variable k, which is something like a cup. The cups, the demonstration of cups. And then variable t, it looks like a container. And in this case, what happens is that when I hit that run button, that blue highlight will start from int kt. When it hit that line, these cups will appear. At first, these cups or containers don't appear until the blue highlights come there. And then when it hits k is equal to 1, and then you'll see that the values 1 will appear inside here, will float from top to bottom until it reaches where the container is. The same applies to when the blue highlights comes to t is equal to 2. 2 will float from top to the bottom and land inside that container, which indicates that variable t now has 2 inside. And then we have k is equal to 2. K is equal to t. In this case, what happens is that the copy of t, variable t, will come out, go up, go all the way and land inside the variable k there. I think let me just demonstrate this with the actual app so that you can see what is happening. Yes, I believe that we're able to do this. By the way, I developed this using C++ or Embarcadero. So when I click that, the blue highlights there, and then 1 comes, and then there's a 2k is equal to t, and then you see that the copy comes and go and replace whatever that is inside the container of k. And then the student should be able to see that the value of k is not added, because the other misconception that we noted from the student is that k is equal to t. They thought that the value of t will be added inside whatever that is inside k, so meaning that it's going to increment whatever that is inside there. So at the end, they thought k is equal to 3, because we did the post-test and pre-test exercises before we demonstrate this. In the same way, we divided the student into control group and experimental group, and see what did they think of the answers before we demonstrate this app. And we compared two groups, the group that were demonstrated with this application in the group that did not have this kind of demonstration. Okay. Let me go back to my presentation. Great. Okay, this is just a demonstration of the same thing. Great. And then we moved to decisions, because now we were fully in the area of animation-based solution. We moved away from the use of physical manipulatives. They worked. I have to say that the use of physical manipulatives works, but because of COVID-19, we were not able to continue in that area. And then we also found that this is more compatible to online delivery as well. And then when we check the other method, the physical manipulative, it was going to be incompatible with online delivery. So this animation program here is about introducing decisions, nested decisions. So what happened, the other misconception that we found here is that students did not understand how nested statement, if statement work. We gave them a program. We divided them into control and experimental group randomly and gave them the exercise. I will show you the exercise, the post-test exercise and the pre-test exercise to see what they knew before our intervention. And then what we found is that a solution that needed a nested statement, student made use of pieces of if statements which were not nesting. Which was a problem because we have problems that need a solution in the form of separate if statements, and we have problems that need a solution in the form of a nested if statement. So in order to treat that, we came up with this animation program where firstly, we have to start from the basics before we get to advanced stuff. I think that's what Prof. Raymond Lister emphasized. Sometimes we neglect these basics and jump to advanced stuff like nested decisions, nested loops, compound statements without emphasizing the basics. So with the simple if statement, what happens is that when that button, the process button is hit, we have an input box there which represents the value that is going to be stored inside the number, and note the arrow on the left there. When it points to the C-in number there, and then you have to enter a number. So in this case, what happens is that 5 is less than 10. Therefore, it's going to demonstrate that number less than 10 will be displayed. And then the yellow square there will flicker several times, which indicates that the if condition is being evaluated, I think for a few seconds. Okay, so firstly, after the user enter 5 and press OK, this is a progress bar. The progress bar will start to move from top to bottom, changing the color from green to gray. When it reaches that yellow square, the yellow square will flicker several times, few seconds, and then it means that the arrow will be there at the if. Okay, I think here it shows what I'm talking about. If that arrow is at the if clause there, this yellow square will flicker several times, indicating that, okay, I'm thinking the condition is being evaluated. Okay, and then when it's done, if the condition is true, then the green color will gradually decreases until it reaches that box C out number less than 10, and the gray color will take over. And then at the end, the student will see that, okay, if the number is less than 10, this is displayed. If the number is not less than 10, then this green bar will remain green, meaning that this code is not touched, it's not executed. Okay, so, and this is what happened. 5 less than 10, and then the code has been executed, and this is the output, number less than 10, and then complete. So what we emphasized again is that this C out complete will execute because it is not under the if clause there. So the execution of this line doesn't depend on the outcome of this if clause. And then we got good feedback when we demonstrated this. Some students understood the use of decisions from the beginning. Okay, so as we continued, we wanted to do something more with the students. So we thought of coming up with a scenario that will include the whole nested statement and the short circuit operator and an OR, so that student can understand the overall concept of nested decisions and when to use it and how it works. Okay, so if we can just read this scenario so that we can understand what will happen in the next slide. And we read this scenario with the students several times until they understand it before we move to the solution and how we model the solution with the animation program. It says you are requested to write an algorithm that shows the process for an employee to get an access into the office. An employee has to go through a gate authentication, then finally go through office door authentication. At the gate, you need to use a gate access card or identity document to get in. If you get access, then the next stage you need to use both office access card and office door PIN code for the office to open. To demonstrate how the authentication from the gate to the office will work, follow the instruction below to complete the algorithm. Okay, prompt the user to enter Y for N Y or N for the gate access. Y means yes and means no. Y and N for identity document. If the gate card or identity document contains the value Y, then proceed by prompting the user to enter the letter YN. Otherwise, show a message access into the company not granted. So the same thing, Y for yes and for no. Check if both office door cards and office door pin contain a Y. If so, show a message access into the office granted. Otherwise, show a message access into the office not granted. So what we wanted to achieve here is that the student should be able to understand that when this employee get to the gate, before the employee can reach the office, at the gate they need either a gate access card or identity document, one of them, not both, one of them. And then when this employee get to the office, two things are needed, and it's compulsory for them, for those things to be provided: office access card and the office PIN code. So for this employee to get access into the office, those two things are compulsory. And at the gate, only one of those things are needed. Okay, so we model the solution by providing something like a flowchart, but this one is interactive. Well, firstly, we had a code. We explained the code before we ran the animation. We explained the code, how we came up with this code so that student can understand. And we know that always will have students who don't understand. And even if you say ask questions, if you don't understand, they won't ask questions. Maybe they're afraid of asking the questions. So this animation really helped a whole lot of them, because after demonstrating, we got a similar response of saying, oh, okay, oh, that's how it works. That's how it works. And that's a good feedback as you are teaching. It encourages you that, okay, as a teacher, I'm doing something right for this student. I'm helping those who are struggling. Okay, so we explained this code, how it works, and how the whole thing, the if statement, what is the purpose of this sign or sign in the end, and before we demonstrated it. And then with the demonstration, I'm going to demonstrate it again, but let me just explain it here. Gate access N, I use the input box here in the form of CIN. So CIN gate cut is N, and then when the blue highlight moves to the next line, it will request for ID cut, and then N, it means no. And then on the evaluation, again, the yellow square will flicker several times. It will indicate that, okay, I'm busy processing the conditional evaluation here. It should either be true or false. And then corresponding text there, which is helping the student, false or false, because we entered N and N. And then at the end, we'll see that, okay, access into the company not granted, because the person did not have the gate card. At the same time, the person did not have identity document. And then we know that it's false or false, which is equal to false. Okay. And then the next demonstration, in case you have either gate card or identity document, the flow will take the true direction, meaning that the gray bar will gradually move from right to left. The green bar and the grayish will go until it prompts the user to enter the office card there, which is no. And then once it's no, it automatically takes the false side, because no and yes will be no. Okay. I think let me just demonstrate how it works so that you can see what is happening. Where is okay, so let's get this side on. Okay. Okay, firstly, it will move like that. I believe you are able to see my screen. And then have gate cut, I will press N, which is for no. Then I press OK. And then have ID cut, no. And then I'll press OK. And then the blue highlight will move to the conditional point, and then the flickering will happen, which will give the student time to understand that the condition is being evaluated. And again, the student should be able to see that the whole code between this brace and that brace is jumped, is totally jumped, because the blue highlight from here jumps straight to the else part. And then access into the company not granted. If I can just reset and start again with different values. So in this case, what happens is that let's put Y and N. Okay, and then the blue highlight reaches the conditional point. The thinking is happening to evaluate either to true or false, and then is taking the true side. So I will have Y for yes, yes, there is an office card, and then I will have no, and then press yes, and then when it reaches the if clause there, the thinking is happening. That flickering means that, okay, I'm thinking, okay, I found it is true or false, which is called false. Therefore, access into the office not granted. Okay, the last demonstration. So I will have, let's just have Y and Y here. Okay, and then it will take the true sides. So this case, in this case, I'm going to use Y and Y. And then again, when it gets to the yellow square, it will flicker, indicating that, okay, I'm thinking about this condition. And then the results are there, true and true, which is true. Access into the office granted. So at the end of the day, they should be able to understand that, okay, this chunk of code will never ever be executed if this evaluation is false. Okay, and then let me close and return to my slide. Great. Okay, this is just one of the animation programs I developed. I have several of them, but I just wanted to demonstrate this one only. I have the one for demonstrating the use of functions. I have the one for demonstrating nesting loops, the one for arrays as well. And then I think the student appreciated the way they understand the whole thing because of this animation programs. And the feedback that I received as I demonstrate this was really interesting, because in the past, as I was teaching this kind of stuff, I didn't get that kind of feedback, that kind of response. Oh, okay, that's how it works. This is really cool. I now understand. See. And then again, another thing which is very important is, we have many tools, existing tools in the literature. Some of them, you find them in the internet for free, but they don't have guidelines. There is no pedagogy that comes with that particular tool. And sometimes we tend to take them and use them and use them the way we think they will be appropriate. And at the end, you may find that you are doing more harm than good. Whatever tool you think is working is not actually working, is actually introducing more confusion into students. So this animation program, they come with guidelines, working guidelines that we have tested. And some of them, we are still documenting them based on our experience of using these animation programs, because they're important. Guidelines of using these animation programs, they're very, very important. If you just take this and demonstrate without understanding the recommendations of the researchers, it might not work for you. Okay. So on that note, thank you very much. Comments and questions, if they are there.
Thank you very much, James. I didn't see any questions in the chats. Bertie, did you receive questions from your side?
Yes, there was a comment in the chat. It asked, did you ever investigate flowgorithm and how it works? It's a very useful tool. You create a flow chart and you can see the memory contents as it changes. You can also view it as the algorithm in any programming language or pseudocode. So that's something to be investigated. It was just a comment. And then Prof. Lister said, nice work, James. And I think, James, we're coming from the same background, know that we need to do every effort for our students to be able to understand the concepts, and what you're doing is nice. And I think we're all working towards creating students that's valuable and that has mastered the problem solving skills, especially for our novice problem solvers and our novice students that's exposed to programming for the first time. So I would really like to thank you, James. And that was all questions. There was also another question, is the tool available for use and how can we access it? James, if you maybe want to answer that question.
The tool is not yet ready because we are still, it is still a prototype, and then I think it will be ready once I'm done with the qualification, because we're still finalizing the tool.
Yes, okay, so I think that would answer. And somebody else, James, did you develop the animation yourself?
Yes, I did it myself.
Right, and then there's another hand up of Nkosikona Dlamini.
You can speak, Dlamini.
Hi, colleagues. Thank you for the opportunity. I just want to check how are these tools evaluated, and when they are evaluated, how are they checked? So this would probably be, if it studies, it's gonna be your findings maybe, or your experiments. What exactly do you do when you say, okay, this tool is great, or this tool is needs improvement? So the evaluation is based on what matrix?
Okay. Firstly, when I designed these tools, I followed cognitive load on multimedia learning theory. So that, you see, when you are developing a multimedia learning material, there are certain steps we have to follow. Then I followed that process in multimedia, cognitive load on multimedia learning. And then secondly, when we test this, we divided the students into two, control group and experimental group, or randomly so. And then the control group, we gave them a pre-test algorithm, which is the same in control group and experimental group. And then when they are done, we divided them. The other group in the control, they had another lecturer, I had colleague who assist me. They did correction without the assist of this tool. And then on the other side, I did correction with this tool. So at the end, we had another algorithm, a post-test algorithm, to check what happened between, did the tool have an impact or not. That's where we did our comparison, and that's where evaluation happened. And we didn't do it once. I think we've been doing it several semesters. At the end, because we are following a practical action research methodology, at the end of a semester, we look at the tool and reflect and see where we can improve, and then the next version get improved, and we demonstrate again, we test again if there is a need to do it again. I don't know if I answered.
Thank you.
There was
There's
some.
more questions, Bertie.
Yes. The question reads, over and above the response from the student, did you see some changes in their marks?
Yes, the post-test, both pre-test algorithm and post-test algorithm, we graded them, meaning that we marked them, we gave either 1 or 2, there is a rubric. And then as we compared the result, we found a good progression, learning progression, based on the pre-test and the post-test as compared to the progression in the control group, meaning that there was significant improvement with the student. And by the way, when we invited the students to come to this kind of a session, we indicated that we are targeting struggling introductory programming students, those who are really struggling. And then another thing that happened is that there were students who came to this kind of sessions, but they were not struggling. But because we have a pre-test and post-test algorithms, we were able to trace those students, because at the end, you find that the student got, if the algorithm is out of 10, he got 10 out of 10 in the pre-test, and then the post-test, the student got 10 out of 10, meaning that there were no intervention necessary for that particular student. So at the end, we scratched them out, because those who needed this, we see them in the pre-test that, oh, okay, this student is not able to do this and this and this, but after the intervention, the student was able to do this and this and this. This one was able to do it in the pre-test, and even after in the post-test, the student was able to do it, meaning that this tool didn't work. I mean, he got it from the beginning, and the same applied to the control group.
There's another question.
Yes, the question reads, will it be possible for somebody to add their own code to your application and then have the code animated?
So no, at this stage, the application doesn't allow a new code, because this one was for teaching purposes, was for emphasizing certain things. So we did not have, the program doesn't allow a new code with the new animation. Perhaps we can look into that in the future. But this one was the main purpose or the main focus was for the teacher to use it for teaching purposes. I think that one will work in the future, but it will focus on the student. The student will have to put a code and it will produce a corresponding animation from time to time as the student practice, something like that.
Thank you, James. We have another hand up from a person. You can put on your mic.
Keith, you can talk.
Hi there. Everybody hear me okay there?
Yes.
Thanks, Steve. Okay.
Okay, great. I'm really excited by seeing this type of thing. Just to bring context, I'm at a high school and I'm teaching from grade 8 right through to grade 12. And it's so evident that when we use these physical interventions, be it at the program level that we're looking at now or the cups or wherever it is, it really does empower the students, because as you say, there are some students who get it straight away and they can almost jump from the problem solving to the coding almost transparently, and it seems you one step. But I'll give you an example. I'm trying to work backwards in the sense of trying to make things more concrete and trying to move from the concrete to the abstract. And particularly at the lower the level you get, the more important it is, but it's important across all the levels. So, for example, the other day I had my kids sorting themselves in an order of height, which was essentially a sorting algorithm, but you don't tell them that. Okay, and they automatically devise structures, and you can see them starting to debate with one another, which is the better way to do it. And then you start to analyze it and say, well, okay, that worked for 10 people. What happens if we had to do the whole grade, for example, or something like that? And that just extends it. And it's amazing how they actually intuitively come up with the solutions or and even the efficiency that they look at. So I don't think we must ever underestimate the importance of the physical examples, because if the pupils can see a need for a solution and how the solution works, it just makes the workload and they go into it with such a more positive attitude as well. Thank you.
Okay, thank you, Keith. I think I agree with you. In our case, I did indicate that the physical solution is good, is recommended. But when we moved to online delivery, we found this animation-based more compatible, and also is also compatible to face-to-face delivery. Noted. Thank you.
Thank you. I didn't see another question. Bertie, do you have another question with you via the emails?
No, I didn't receive any, and I just checked now. So I think that concludes the questions.
Thank you very much, James. I also think the teachers are very excited. I think this is a real opportunity to get this program finished and distributed to the teachers for use in the schools, as well as the novice programming in other places. I really think this is an exciting project that you're actually doing, especially for our people that mostly have children coming from school without any IT, in most times not CAT at all, and it is really helping our students to start thinking correctly and do problem solving. Thank you very much for your presentation. We really appreciate it. Then that is the end of today's proceedings. I hope you enjoyed today's proceedings. We will see you tomorrow morning at 9 o'clock when we start again with Prof. Lister. And remember, tomorrow we're going to do examples of question papers and see on the levels of Bloom's taxonomy, and that he comments on the Bloom's taxonomy from that side. And we will definitely ensure that we get the practical examples. And tomorrow we also got a teacher that is going to talk to us, that is going to talk about his experience from a township school, how to do IT in a township school. So thank you very much for your time today. I hope you've learned a lot, like I've learned a lot. And we hope to see you all tomorrow. Thank you very much. Bye-bye.
Bye-bye. There's a question regarding if there's another form. It's not necessary for today. We decided to combine it into one for tomorrow because we're going to treat it as one kind of session. And we would just like to thank everybody for their great inputs, the nice questions that was asked. And thank to all our presenters from the bottom of our heart. We really learned quite a lot from you, and it's informative. And this morning, as it's cold in winter here, I didn't even mind because I could sit and I knew that I'm going to learn something valuable. Thank you, ladies and gentlemen. Have a blessed afternoon. We're going to see each other then again tomorrow, just before 9 o'clock, and Prof. Lister the same time as today. Thanks, everybody. Thanks, Chris. Thanks, Prof. van Vieren. Thanks, James, and to all our other presenters. Roxanne, we really appreciate it. Have a blessed afternoon.